live. Well, good morning, everyone. Welcome to the Salmon Prize Symposium. Very excited to see all of you here bright and early, especially after last night's festivities. So I expect some people are a little hungover, but it looked like it was a good time. Who here was able to attend the dinner? Yeah, good. Yeah, well, hope you had a good time this conference. I think we made a record for the chapter where over 400 people signed up. So it was been a really good success and appreciate everyone coming out. So a little bit of background on the Salmon Prize, a little bit of background on me. So I do not do salmon forecasting. I run competitions for my day job. So I run the Anglers Atlas and MyCat. And what we do is we recruit anglers to basically be our field staff, but we do it through a competitive framework. Sometimes we call it a tournament. Sometimes we definitely don't call it a tournament. It's called the bio game. It's called a challenge. But using a competitive framework to recruit anglers to achieve whatever experimental designs we're after. In some cases, it's biosurveillance, where we did a North America-wide event tracking the presence, prevalence, and seasonal variation of a virus called blotchy bass. Other times, it's getting a predator control study or invasive things. So we use a competitive framework to do that in order to achieve research-grade data through anglers. So that's my background. That's how I got into this. And maybe I'll just flip to the next slide here, because the whole way this project started was 2 years ago at our conference in Bellingham, when a fellow named Dick Beamish, I didn't know the guy, but that's because I'm from a different space. Apparently he's a big deal in fishery circles. And he was giving the plenary talk, and he says, how is it at a time we see a collapse of salmon on the west coast of British Columbia? At the same time, we're seeing an all-time record high of salmon biomass in the North Pacific. And that we don't know the answer to that question is both a challenge if you're one of the managers. But if you're geeks like us, it's like, ooh, there's mechanisms at play that are changing that we can't really dial into using the traditional conventional methods. And so how do we start going after that? I know he launched a massive midwinter survey in the North Pacific with Professor Kaganovsky, rusty old Russian research vessel that I think Lori Whitecamp, sorry she couldn't make it here, but she I've seen presentations she's given on the discoveries that they've done when you're able to be out there in the North Pacific. Now the challenge with that is that very expensive and hard to do, and you still only get small sample sizes. So I thought, could I apply a competitive framework where instead of we get anglers competing for a prize or for whatever, we get research teams competing. And in this way, what we have to do is we have to have a standard common metric where we gauge, can mark everybody against so that we know it's reliable. And I thought, well, the salmon run numbers are as close as we can get to actually consistent numbers that are verified, and as close to the truth as we can get. And we get that over run after run after run. Maybe that's what the competitive competition is about, because then I can create leaderboards, then I can create a structured competition that doesn't require a lot of judgment. It's just like who gets closest to those numbers, that's how we rank them. But in addition, because we do want to get after mechanisms, that's going to be the holy grail. I don't know if it's possible through this method, but that was the idea. And if I get enough competing teams out there with different approaches, and I want people with different ideas, different theories, different ways of thinking about what's happening in the ocean and embedding that within their forecast, within the models. And I'm thinking at a very layman's term, just covariates. You know, what sort of covariates are you including in your predictions? And the idea is if I can get a broad enough cross section, you know, think of like if I can get 100 teams, that's sort of the dream, 100 teams. Maybe if we get $1 million prize, we get 100 teams competing. All sorts of variations of models and forecasts. The idea is the covariates that are clustering at the best models will start to repeat themselves. And maybe there it's almost like an indicator, because it's still just correlation, an indicator of mechanism. That's the dream. I have no idea if it's even close to true, but that was sort of the background, so they got me into this. And so that's how I got sort of brought into this space. And I've got shiny object syndrome, so it's like, oh, this is kind of fun. My team on the angler side doesn't like it because I get distracted, but this has been a really interesting exercise for me, getting a sense of how the models work. So anyways, that's the origin of how this all took place. So the Salmon Prize competition to see which team can best predict the number of returning salmon. The first competition, well, we did a beta test with I think Haley and yeah, who were on the Haley, Curry, Cunningham, and Tanya, just to get a sense of how it was working. But we'd already knew the numbers there, so we know it wasn't a real test. But the first full proper competition was called the Sockeye International. 14 runs had to be predicted, 8 from Bristol Bay, 5 from the Fraser River, and then the entire Columbia, because they don't really tease apart the numbers for sockeye runs there. And the idea is, yeah, sure, you might get that 1 run right. Good luck getting 14 runs right. So it's not so much of a guess at that point. And in addition, it's not just that number. We want to see what your method is. You know, what's your approach? How did you go about doing this? And then let's see, can we come together and start sharing those methods so we can learn from each other on what's working, what isn't, and how various people approach things slightly differently. So how did it work? Basically, the teams register for the competition through our website. You enter the forecast, you enter a title and an abstract about the method, you enter your R code, but not everybody uses R code, so you know, some people can upload a spreadsheet like Alec did this all through a spreadsheet. And just basically gives us more context, because what we're really trying to get at is ultimately we want to get to mechanisms, but it's going to be several steps to get to that point, if we can get there at all. And then you make it fun. You make it, you put prizes on, you incentivize with cash. It's worked well with anglers. We thought maybe it'll work well with scientists too. The first 5 teams submit forecasts win $200. And that was just making sure I could get at least some forecasts. And so automatically, if you get your submission in and it's one of the first 5, you get $200. So that was an easy first prize. The second is who can get the best predictions for all of Bristol Bay? Who can get them across all of the Fraser? Who can get them for the Columbia? And then a prize for who gets overall. And it's we use mean absolute percent error, make percent error, the way I think about it, to basically score the overall winners. And then this is basically the poster that we've set up to do that. So just to get a bit of an overview on the runs. So Bristol Bay, there are 8 runs here that we're pulling. I'm not going to try and pronounce them all. I will mispronounce every one of them, I expect. But that gives you a sense of the runs there. The 5 Fraser runs. I wasn't sure which runs to choose, but I had a discussion with Catherine Mickelson. She was saying these are the ones we should go after. So basically, I think that's Raff, right? Quinnell, Chilco, Stilaco, and Stewart, and then just the full Columbia run as well. So, although I think most of them go up here, don't they? So that gives you a sense sort of where those runs are. Now, give you a sense of the teams. We had 8 teams competing, and I think we've got almost all presentations or presenters here, either here in person or here online, and they all submitted predictions on for the forecast. Here's basically what a breakdown of all the forecasts look like. Now, the interesting thing when I'm looking at this, being a layperson, it is interesting. So here are Bristol Bay, the first 8. They all tend to cluster in one direction or the other. You get an occasional outlier, like there and there. But for the most part, it's amazing how they're either all under or all over. Now, I'd be really curious to see some of the experts' thoughts on that. Columbia, all under, but that was because it was an epic run. I think it was all-time record high of sockeye in the Columbia system. The Fraser is the crazy one, and this is what I keep hearing talking to people. So these numbers are wild in terms of our ability to know what's going on in the Fraser. Really, really wild variations here. Now, I did hear somebody, and maybe somebody in the audience can fill me in. The actual number of returning salmon on the Chilco, was that before or after the slide?
Before the slide, so they're the actual run size, so it's not after the slide.
Yeah, that's what people were saying. It's like, well, the run or the slide killed it, but no, the slide had nothing to do with it because the run had already come in at that time. Yeah. Okay, good to know. Yeah, and so this gives you a sense of the variability of the Fraser system as well, because you are seeing over and under there, which is really kind of interesting. Very different sets of patterns that we saw in Bristol Bay. Now, a key part of this is what I want to do is be able to bring together the people who are competing with the people who do the formal forecast, so we can start sharing ideas and sharing methods, So we get a sense of sort of how the official forecasts are done and modeled, and then how people who are just thinking about this independently approach this and seeing if we can get some cross-pollination. So I did manage to get the run numbers. The management run numbers are pretty close, I think. They're almost the final numbers, I think. Catherine, I got them from you. So these are as close to the final as we can get for the Fraser. I think for Bristol Bay, they're the final, and Columbia, they're the final. So I'll just start in Bristol Bay. So if you look here, the official forecast is in red with a yellow highlight. And you can see some of the models, the green one. And this is interesting. Here, I'll move this thing out of the way so we can see the participants. Sea mist. So this was Brian Burke's model, did quite well there. And it actually did fairly well throughout the whole thing. So there's the official forecast, about average. Official forecast was best there, was the best one there. We had a number of our predictions basically better than the forecast there. This is kind of middle of the pack, kind of middle of the pack, middle of the pack. So overall, the competitors that were competing in the competition actually were certainly in line with the official forecasts. Columbia as well. Yeah, Chilco's a crazy. And Quinnell, I took out one of the outliers. One was 8,000%. So just take that one out entirely. But it's just to give you a sense of sort of how the competitors' forecasts performed against the official forecasts. Now, I will do the announcements of the winners at the end of the presentation. So I'm gonna hide this the rest of this presentation now. And what we're going to do is we're going to go through each one of the forecasters and their methods, how they came about developing their methods. So let me just see if I can collapse this down.